Good morning, dear students. So right now we are going to do imperfections in a solids. So this one is called as a defect, or we call it as a disordered. Any deviation from completely ordered arrangement of a constituent particle is called is a crystal. Okay. Any deviations from completely ordered arrangement of a constituent particles in a crystal, okay, this is in a crystal, is called as what? Disordered or defect. So for that, let us try to understand. Suppose the molecules, the constituent particles are arranged here like this. Here also it is arranged this way, but here it is only 3. So this is also a kind of defect. In each row there are 4 constituent particles, but here it is only 3. So this is deviations from the completely ordered arrangement, right or not? So this one will be, we will call it as a defect, or we call it as what? Disordered. Once again I'm telling you, this is the completely arranged constituent particles. This is the order of the constituent particle. 4 constituent particles are present in each row, but in the last row you see here 4, but in the middle row there is only 3 constituent particles. That means what? They have not obeyed, they have not followed the ordered arrangements which are followed in others row. Therefore this one will be treated as what? The imperfections in a solid, or we call it as a defect. Okay, dear students? Okay, hope you have understood. Okay, fine. Next we are going to discuss, okay, hope you have understood this. Next let us discuss okay, next is what? Types of defects. So types of defect, we are going to discuss types of defects. Okay, so type of defect, basically there are 2 types of defects are there. One is point defect, and another one is, second one is what? Line defect. So what is point defect? Let us try to understand. So the defect which this point defect, it is the defect, okay, which arises, okay, which arises due to the, okay, which arises due to the irregularities, IGULARITIES, due to the irregularities in ideal arrangement. Okay, due to the irregularities in ideal arrangement of the atom around a point. Got it? So what is point defect? It is the defect which arises due to the irregularities in ideal arrangement of the atom around a point. So that means what? This defect which will be this defect, basically it will occur okay, around a particular atoms. It's not that it will be occurring in throughout the crystals. No, it will occur only around a particular atoms. So that's why it is called as what? Only around a particular point. That's why this defect we call it as what? Point defect. Okay, this defect basically, again I'm telling you, suppose these are the constituent particles or the atoms. Okay, example, these are the things. So this defect will not arise like this here. It will arise only around a particular atoms only at a particular point it will be there. This defect will be there. So that's why we call this defect as what? Point defect. Okay, next one is what? Line defect. So what is the line defect? Let us try to understand this. The defect which arises, okay, it is the defect, line defect. Okay, it is the defect which arises due to the irregularities in ideal arrangement irregularities of ideal arrangement in entire row or column, in entire row. Okay, that means was this defect will be arising. Suppose this is a constituent particles here, like this is a constituent particles here, this is a constituent particle. So if this defect is there, this defect will be like this throughout the entire lines, or it will be like this, in this way. Got it? Not only one but entire line will be having the defect. Got it? So this kind of defect we call it as what? Line defect. Okay, this is the defect which arises due to the irregularities in ideal arrangement in a row. Okay, so in a row, if there will be in the entire row there will be an irregularities from the ideal arrangement. Ideal arrangement means normally how all the constituent particles are arranged, that is called as ideal arrangement. Under that, if there is some faults, some defects will be there in one line or two lines, that will be called as what? Line defect. I hope, dear students, you have understood. It was not that difficult. Okay, so after studying about the line defect, point defect, now we'll study about the different types of line and point defects. Okay, got it? Fine. So different types of line and point defects we are going to study now. So point defects in solids are two types. Okay, there are two types of point defect. Okay, there are two types of point defect. The first point defect we have, we call it as vacancy defect. Vacancy defect. Okay, so vacancy defect is what? When the atom, okay, vacancy defect is nothing but okay, when some of the lattice site is vacant, okay, when some of the lattice site is vacant, then it is said to be vacancy defect. Okay, for example, I'll tell you, suppose this is a crystal here, 1 2 3 4, 1 2 3, here it is vacant, 2 3 4, here it is vacant. So this is what? This is nothing but vacancy defect. This is the vacant spaces, right? These are the vacant spaces. So this kind of defect we call it as what? Vacancy defect. Why? Because here the some of the lattice sites is vacant. This is called as the lattice sites. So here the constituent particles are not there. So we will call this as what? Vacancy defect. Okay. So this is the vacancy defect. Diagram also it's important. So next one is what? We have next type of interstitials defect. Interstitials defect. Interstitials defect. Interstitials defect. In this type of defect, what happens? You will see that when some of the constituent particles occupies the vacant interstitial positions. Okay, when some of the particles occupies the vacant interstitial space, then we call it as what? Interstitials defect. What will happen here? Here all the constituent particles will be there in their lattice sites. Okay, all the constituent particles are there in their lattice sites, but beside that also, these are the constituent particles which are present at their lattice site, but beside this also you will see that in the gap there will be some extra constituent particles will be present. So this kind of defect we call it as what? Interstitials defect. These are called interstitials positions. So beside the regular arrangement, they will have that much constituent particles in their lattice site. They will have all the constituent particles in their lattice site, but beside that, in the interstitial space, that in between the gap also, there will be one or two extra constituent particles. So this kind of defect we call it as what? Interstitials defect. Hope, dear students, you have understood it. Okay, pause the video and take down. Okay, dear students, now we are going to study the point defect in Statumetric compound. Okay, so point defect in a Statumetric compound. First of all, we have to understand what is a Statumetric compound. Okay, Statumetric compound, what is that? So it's very simple. Those compounds in which the number of positive or the negative ions are equal as indicated by the formula is called as Statumetric compound. For example, NaCl. So in this formula it says what? Na is 1, Cl is 1. So when you write their ions forms, it will be giving us Na positive, 1 positive, and Cl 1 negative. So it is exactly the number indicated by their formula, and the charge is exactly the number indicated by their formula. So NaCl will call as what? Statumetric compounds. Okay, got it? So this is the compounds in which the number of positive and negative ions are exactly the same as indicated by their formula. So here the formula indicates NaCl, 1 positive, 1 Na and 1 Cl. So here also you see 1 positive charge, 1 negative charge. So this kind of compounds we call it as what? Statumetric compounds. Okay. So now we are going to see the point defect in Statumetric compounds. These point defect in Statumetric compounds can be divided into two types of the defects which are there in the Statumetric compounds can be divided into two types. What is this? The two defects present in a Statumetric the two types of defect present in a Statumetric defects are: number one, Schottky defect. Okay, in the Schottky defect, what happens? You will see that some of the atoms or some of the positive or negative ions will be missing from their lattice site. When some of the atoms or ions are missing from their normal lattice site. So see here, normal lattice site 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1. This is the regular arrangement. In this regular arrangement, you see two places are vacant because here the ions, one ions here and one ion here, they are missing from their normal lattice sites. So this defect we call it as what? Schottky defect. Okay, when the normal ion, this is not vacancy defect, this is also we can call it as a vacancy, but here the ions are missing from their lattice site, not the atoms. Okay, so here the ions, two ions are missing from their lattice site. So this kind of defect we call it as what? Schottky defect. Schottky defects. The sites which are vacant, now which are left vacant by the missing cation or the anions, by the missing ions, are called as what? Holes. This is called as a hole. This vacant places is called as holes. Okay, here here, since the cation has left, so it will be called as cationic vacancy. Cation vacancy. Got it? And if anion is there, then we call it as anion vacancies. Got it or not? If positive is there, then cation, and if negative is there, then anion. So here it is anionic vacancies. Okay. So once again, what is Schottky defect? When some atom or ions are missing from their normal lattice site, then the defect is called as what? Schottky defect. The site which is unoccupied, which is left vacant, is called as a hole. Okay, dear students, hope you have understood. Okay, now we are going to see the conditions causing the Schottky defect. Means what are the conditions because of which Schottky defects occurs. Okay. So this part is very important. All of you need to study it properly. Okay, sometimes question has been asked in the board examinations and as well as competitive exams. Okay, so conditions causing Schottky defect. Okay, what are the conditions because of which Schottky defect occurs? Conditions causes, okay, or condition causing Schottky defect. Causing Schottky defect, SCHOTTKY, Schottky defect. So what are the conditions because of which Schottky defect occurs? The first condition is high coordination number. The first condition for Schottky defect is what? The first causes of Schottky defect is what? High coordination number. High coordination number. That means what? High coordination number means one single atom is surrounded by many other atoms or ions. So that is one reason for the cause of Schottky defect. Got it or not? One single atoms or ions will be surrounded by many atoms and ions. That is called high coordination numbers, because of which this defect will take place. Next, the second reasons for this is all the ions are almost of same size. So these are the two reasons causes for Schottky defect. So what is the first cause? The high coordination number, and second cause is what? All the ions or atoms present in statutometric defects, they are almost same size. So that is why this Schottky defect occurs. Okay. Now we are going to see some examples in which Schottky defects occur. Some of the statutometric compounds in which Schottky defect occurs, like NaCl. The coordination number is very high here. Okay, here 6 and 6 it is. NaCl, KCl, KBr, KCl, KBr. Okay, and CSCl, CSCls, and AgBr. So these are the compounds in which you will see that Schottky defect will be occurring. Okay, got it? Now, got this point is clear? Okay. Now few things are there we will be discussing at the last. What are the causes? Causes we have studied. Okay, what is Schottky defect we have studied. Now we will study Frankel defect, and at the last we will study the consequences of Frankel and Schottky defect. Okay. Okay. So hope you have taken down. Now the second type of defects we have is what called as Frankel defect. Frankel, Frankel defect. So Frankel defect, what is this defect? In this you will see, in this defect, this is the defect in which the anion this is the defect in which okay, so Frankel defect it arises when an ion is missing from the normal positions. When the ion is missing from the normal position and occupies an interstitial site between the lattice point. Okay. Fine. So this is the defects in which the anion is missing from the normal lattice site and occupies the interstitial site. Okay, so this is the defect in which the anion is missing from the normal lattice site and it occupies the interstitial sites. Got it? So Frankl defects, for example, let us write it 1, 2, 3, 4. A positive, B negative, A positive, B negative. Then again B negative, A positive, and B negative, A positive. So here A positive, here B will be vacant, here A positive, and here it will be B negative. Okay, so here you can see that the cationic ions are leaving. Okay, okay, so here it will be leaving their sites. Okay, got it? It will leave their sites, the cations, in which the ions are missing, from the normal side. Ions are missing. So let's assume that here A, B. So this part from here it has left and it occupies the space here. Got it or not? So they are leaving from the interstitial, they are leaving from their lattice sites and they are occupying the interstitial positions. So this kind of defect we call it as what? This kind of defect we call it as Frankl defect. Okay, got it? So this kind of defect we call it as Frankl defect, in which the ions are missing from their normal position and they occupies after coming out from there they occupies the interstitial positions. Okay, got it? So what are the conditions for Frankl defect? What are the conditions causing Frankl defect? We will be studying now. Conditions. Okay, condition causing Frankl defect. Condition causing Frankl defects. So the first condition is coordination number is low. In this you will see that the coordination number is low. Coordination number is low. Second point is what? Anion are much larger in size than the cation. Here anion are much larger in size than the cation. So these are the two causes for Frankl defect. Coordination number is low, anion the size is much larger than the cation size. Okay. Okay, take down the notes. Okay, dear students, so now we are going to see the consequences of Schottky defect. Means what are the things which happens because of this Schottky defect. Okay, what happens in the crystal because of the Schottky defect and the Frankl defect we are going to see. So you can look at Schottky defect. Because of the Schottky defect, what happened? it increases the electrical conductivity of a crystals. How it increases? Because it generates a hole, and that hole is useful in carrying the charge. So that's why the electrical conductivity of the crystal will increase. Why? Because this defect generally arises when some of the atoms or the ions are missing from their lattice site, right? So that absence will generate a holes, and that holes will help in conducting the electricity well. Okay. Next is what? It decreases the density of the crystal, as we have already seen that the crystals are missing from the ions are missing from their lattice site, right? So just imagine here the ions will be missing. This one ion is missing, then definitely the weight of this, it will not be there. So definitely what will happen? Density will decrease, because in Schottky defect there is a absence of ions from their lattice site. So lattice site, if the ions are missing, then definitely the density will decrease. Okay. Another thing, it decreases the lattice energy. Lattice energy, that means stability also, it will be decreased due to the absence of the crystal. You can say due to the absence of the ions from a lattice site. Okay. For what are the things which changes in Schottky defect? Schottky defect will change the electrical conductivity of a crystal. It will increase. It will decrease the density of the crystal, and it will decrease the lattice enthalpy or the stability. Okay. Next, consequences of Frankel defects. So by Frankel defect, what are the things which happens? So electrical conductivity here also it increases because they are generating a hole. Okay, it does not change the electric density. So here density will not change, because in Frankel defect we have studied that they will be leaving their positions, lattice site, and they will occupy the interstitial sites, right? These positions they will leave and they will occupy here, right? So that means though they are leaving their lattice site, but still it is there in the crystal itself, so the density is not going to change. Density will remain same. It decreases the lattice energy. Here also lattice energy is decreased. Okay. Here lattice energy does not change. Okay, here lattice energy will not be changed. And in third point, it increases the dielectric constant of the crystals. Since similar charges are present very close to each other, so what will happen? The dielectric constant of the crystal will change. Okay, or it will be increased because of the closeness of the same type of ions. Got it? So these are the consequences of Schottky and Frankel defect. Now we are going to see the differences between Frankel and Schottky defect. Okay, so you can pause the video and take down. Okay, dear students, so as per the new syllabus, this is our last topic. Okay, so and it is very important. Mostly in the board examination it used to come. Okay, so it becomes very important. Very simple it is. Let us try to understand difference between Schottky and Frankel defect. So Schottky defect is what? Schottky defect is produced due to the absence of ions or atoms from where? From their lattice site, from their original positions. Whereas Frankel defect, it is produced when some ions or atoms are displaced from their original position and they occupy the interstitial position, means in between the atoms or ions there is a vacant space, that is called as the interstitial space. So they leave their original position and they go and occupy the vacant space. So that is called as the Frankel defect. Schottky defect, generally it changes the density of a crystals. That means the density of the crystal will be reduced. Whereas in Frankel defect you will find there is no change in density. They have just displaced it. They did not leave the crystal. So here density will remain unchanged. Next, Schottky defect, it is shown by ionic crystals. Okay, this Schottky defect, it is shown by the ionic crystals which has a high coordination number. For example, NaCl, CSCl. Okay, CSCl, it has coordination number 6:8, and NaCl it will be 6:6. So their coordination number is high, so they show Schottky defect. Whereas Frankel defect is shown by ionic crystal having low coordination number. CN is coordination number. Example, they have given AgCl and ZnS. Okay, so this is the basic 3 points of differences between Schottky and Frankel defect. Dear students, you have to pause the video and take down the notes, okay, if you want for your examinations. Okay, so here we come to the end of your chapter 1. Of course, there are many more topics are there, paramagnetic, dimagnetic, and all are there, but as per the new syllabus, it is not included in your new syllabus, so we are leaving it. So dear students, all of you study hard, only few months are left, and try to excel in your examinations, try to pass the exams with flying colors. And here we come to the end of the chapter 1, revisions, class 12 chemistry. And students, if you find that these videos are helpful to you, you are learning from these videos, then don't forget to subscribe the channel and share the video with your friends. Thank you.